Hey guys, Mr. Krieger. This is going to be starting on lesson 7, which is there's going to be 2 parts: radian and degree measure conversions, and learning the equation of a circle. Before we actually start, I just wanted to show you a computation. I wanted to show you that Celsius is a way of measuring temperature, and so is Fahrenheit, and you could actually convert between Celsius and Fahrenheit. Here, if you put in a Fahrenheit value, you'll get a Celsius value. 2 conversions you probably already know, like right off the top of your head, is that 0 degrees Celsius is 32 degrees Fahrenheit. Also, 100 degrees Celsius is 212 degrees Fahrenheit. Just to show you, so if you put in a Fahrenheit of 212 here, 212 minus 32 over 1.8, sorry, that's a 212. That's 180 over 1.8, which is 100. Like we said, it should be 212 equals 100. Let's just try another one. Let's say you had a Fahrenheit of 60 degrees. So let's see what the Celsius temperature would be for a Fahrenheit of 60 degrees. So 60 minus 32 is 28, and 28 divided by 1.8 is about 15.5 degrees. So 60 degrees Fahrenheit is about 15.5 degrees Celsius, okay? So there is a similar type of conversion we can do in for degree measure, especially when you get to algebra 2, when you do trigonometry there, you're going to have to know another measure called radian measure. All right, it's like degree measure, but it's sort of like a similar kind of conversion, not exactly the same, of course, but it's similar to converting from Celsius to Fahrenheit. We'll want to convert degrees to radians or radians to degrees. You're going to have to learn how to do this pretty, be able to do it pretty well. All right. So up until now, we've only measured angles in degrees. There's another way to measure angles called radians. It's a relatively straightforward process to convert from one type of measurement to another. Here's the fact you should know. 180 degrees is pi radians. Let me write that a little larger. 180 degrees equals pi radians. Okay, so pi actually stands for what you know it stands for, about 3.14. So 3.14 approximately radians is equal to 180 degrees. So here's a conversion. Suppose we wanted to know what 9 degrees was in radian measure. Well, 9 degrees would be pi over 2 radians. Since 180 degrees is pi radians, if we divide both by 2, that would be 90 equals pi over 2 radians. So that one's pretty easy. So what do you think how many radians would be in 360 degrees? So consider that if there's 180 degrees for pi radians, how many radians would there be for 360 degrees? So since we would have to double 180 to get 360, we would double the pi to get 2 pi radians, and we would know that 360 degrees is equal to 2 pi radians. Okay, that's nice for conversions where all you need to do is half or double. But what if you wanted to do something like convert 47 degrees into radians? Okay, that'd be a lot more complicated. Well, because of this fact, we can always make a proportion. Now you can see how important proportions are. We use them so much. So for example, since we know pi radians equal 180 degrees, we could then put whatever we know, let's say in this case a degree measure like 47 degrees, we could put 47 degrees here and an x there, cross multiply and solve for x to find out what the radian would be. All right, so let's do a few so you can get the hang of it. You can see how to do it. Like convert 75 degrees into radian measure. All right, so we start off with our proportion. Pi over 180 equals, now we don't know the radian measure, so we're going to put an x there, but the degree measure is 75. So you see what's happening here? Pi radians is to 180 degrees as this missing radian measure is to 75 degrees. So you have the degrees on the bottom and the radians on top, as they should be. And now you could cross multiply and solve. So what you're going to get is 180x equals 75 pi. Divide both sides by 180. So you're going to get x equals 75 pi over 180. That could be reduced because 75 over 180 actually reduces because, I think 15 goes into both those numbers. 15 goes into 75 5 times. 15 goes into 180 12 times. So you would get that 75 degrees is 5 pi over 12 radians, or 5/12 pi radians, okay? All right, let's take a look at another one. Convert 1.5 pi radians into degree measure. All right, so we can use our proportion there. On the left side, we always use that ratio, pi over 180. And on the right side, we're going to put what we know, and what we don't know, we're going to leave an x. In this case, we know radians, that goes on top. So 1.5 pi radians over x degrees, because that's what we don't know. Let's cross multiply, so you're going to get pi x equals, well, now 1.5 times 180 is 270 pi. By the way, the pi's will divide out. And you're going to get x equals 270 degrees. So 1.5 pi radians is the same as 270 degrees. So you can see how easy it is just to use this conversion to convert from degrees to radians, or from radians to degrees. Okay, so now you can try some on your own. We're going to want to convert, the next one is to convert 30 degrees into radians and leave in terms of pi. So as you saw before, we would do pi is to 180, as here we know the degrees, but we don't know the radians. We'll put an x on top because that represents the radians, and 30 degrees on the bottom. And again, you guys can work this out on your own. You don't need, you could stop the video, try them, and then watch the video to make sure you got them right. Okay, so we cross multiply here, we get 180x equals 30 pi. Divide by 180. And we want to simplify. 30 over 180 actually reduces to 1/6. So you get 1/6 pi is the number of radians, or you could write it pi over 6 radians is the same as 30 degrees. Okay, number 4, convert 2 radians to the nearest tenth of a degree. Oh, I just want to point out something to you. In the problem number 2, we were given 1.5 pi radians. So this time we're given a radian measure without the pi. That's okay. We still use the same formula and everything. Pi over 180. Since the radian measure is what's given, we put that in the numerator, and we're missing the degree measure so we're going to put that in the denominator. Cross multiply. Pi x equals 360. Divide by pi. And you get x equals, now it says to the nearest tenth of a degree, so we'll do 360 divided by pi, 114.59. That becomes 114.6 degrees is the degree measure that's equivalent to 2 radians. Okay, let's see the next one. Convert 150 degrees to radians. All right, same thing. Pi is to 180, as this time we know the degree measure, so we don't know the radians. Put the 150 on the bottom, cross multiply. 180x equals 150 pi. Divide both sides by 180. And that's going to reduce to the nearest tenth, 2.617, which becomes 2.6 radians. Okay, here is a quick shortcut for you. This is a nice shortcut when you have pi in your radian measure. Because we know pi is equivalent to 180, instead of setting up a proportion like we did over, here's another example, like we did over here, we set up a proportion. But if you're given pi, here's a nice shortcut, so you don't have to do a whole proportion. You can merely substitute pi with 180. After all, the pi kind of represents that you have a radian measure. Degree measure, the pi is equivalent to 180, so you can replace that pi, which was over here, with 180. And just do that operation, 3 times 180 divided by 4. You do those computations, and you get 135 degrees. 3 pi over 4 radians is 135 degrees, and at least you didn't need to set up a whole proportion. That's a nice shortcut when pi is included, okay? All right, now we're going to move on to something else. We're going to move on to the equation of a circle. Now, you know that lots of graphs have equations associated with them. In fact, before I even do the circle equation, you know that a line has the form, y equals mx plus b, or you could say, I'll make up one, y equals 3x plus 5. A parabola would have an equation that looks something like this. Y equals like x squared plus 5x minus 7. So when I'm talking about the equation of a circle, I'm talking about something like this. I'm not talking about finding the area, finding the circumference or something and using a formula. I'm talking about the actual equation that will give you the graph of a circle. So what does this equation look like for a circle? Well, the equation for a circle, there's two things you basically need to know before I even tell you anything. The two things that will tell you where a circle is located and how big it is its center and its radius. Now, if you happen to know the center of the circle is at the origin, that's the point 0, 0. And let's say the radius, we'll just leave the radius for r right now. Then the equation of a circle will be x squared plus y squared equals r squared, okay? This is if the center of the circle is at the origin. I'll show you what happens over here if the center is not the origin. And this side, it's going to tell you the size of the circle. So the r represents the radius of the circle, okay? R represents the radius of the circle, okay? And this is what the equation looks like. Let's just compare it to like the other equations. With the line, there was a y and an x, but no squares. With the parabola, there was a y and an x squared. And with a circle, it's going to be x squared and y squared. So let's take a look. Graph a circle that has a center at the origin and a radius of 3. So that is going to look like this. First of all, the equation is going to look like this. X squared plus y squared equals 3 squared, or x squared plus y squared equals 9. That's the equation of this circle. Now we want to graph a circle that has a center at the origin, so that's going to be the center. Now, the circle is going to be like this. How do I find points on the circle? Well, I know that since the radius is 3, I'm going to move 3 units up, 3 units right, 3 units down, and 3 units to the left, all from the center. Obviously, there are other points, but it's hard to find those points. But at least starting from the center, finding 3 up, 3 right, 3 down, 3 left, then you're welcome to use a compass. Put your fixed point here and then open it up to here to make a nice circle. Or the way I like to draw my circle, if I'm doing it freehand, is just to do each quarter. Because I'm just going to make like a curvy part there, and a curvy part there, and a curvy part there, and a curvy part there. And it's going to get me approximately what I'm looking for. And here's the radius, which is 3 units. But I want you to notice that the equation of the circle actually has a 9 there, not a 3. It's 3 squared. It's the radius squared that goes into this position. All right? Let's try some of these problems. So when I see an equation like this, I say, I know what this is. An equation of a circle has an x squared and a y squared in it. At least from my point of view, at this point, I wouldn't think that the center is anything but the origin. I wouldn't know what that looks like so far. And the radius is not this number, it's the square root of this number. So the radius is going to be the square root of 16, the radius is going to be 4, okay? Now if you take a look at the next problem, you say, oh, that looks a little different from this. Yes, what you want to do is you want to get the x squared and the y squared by itself. You don't want to have those 2's there. So you literally want to divide out the 2, which gets you to x squared plus y squared equals 15. Okay, it looks better. It looks more like that. Center we know. We don't know anything else but center of 0, 0. Now the radius is not this number. It's the square root of this number. Since it's not a perfect square, we're going to be stuck with the radius being radical 15. Okay? Now, the next thing is, what happens when we have a radius we have a center of a circle that's not at the origin? We haven't seen that yet. Well, let's take a look what happens. Okay. So, for a circle that's not centered at the origin, what you're going to see is the following. This is what the equation is going to look like. It's going to look like x minus something squared plus y minus something squared equals r squared. So the only difference is that in the past, it was just x squared plus y squared. Now we've got these parentheses with minus stuff in them, right? Well, here's what we're going to know. We're going to note that h comma k is the center of the circle. Okay, so that's one thing that's different. So let's say H and K were, but let's say H was here and K was here. The center of the circle will be there, and then whatever the radius is, the circle will be around that point, HK. All right. So how do we write the equation of a circle if we don't have if we're given a center that's not the origin? Figure out the center and radius and write it down. So you're literally going to write down, okay, what's the center, what's the radius? Square the radius and change the signs of those numbers for the center. I'll show you what I mean. Let's take a look at an example right here. This problem is a circle, clearly, right? The center of this circle is 2 and -3. So I'm going to write that down. Write down the center and the radius. How am I supposed to figure that out? Okay, well, the center of the circle is here. It's the very center. So therefore, the radius has to be these two boxes. The radius is going to be 2, right? Now, when you write your equation, it's supposed to look like that. This is your H and this is your K. But it's telling you to do minus them. So basically, we're going to be taking that sign and switching it. So if it's a 2, you put a -2 in there. Don't forget it needs to be squared. For the y, it's going to be minus that. So minus -3 is going to be +3 squared. Let's talk about this for a minute before I finish up the rest of the equation. This is the key thing. Change the signs of the center when you put them into the equation. If there's a 2 for the x, it's going to be x -2. If there's a -3 for the y, it's going to be a y +3. So just know to change those signs when you put them into the equation and you're good. And the radius is 2, so we're going to square that. You're going to get 4. So that's the equation of a circle that has the center of 2, -3 and a radius of 2. All right, so let's try the last problem. You should try this yourself and see if you could figure it out. How can we write the equation of a circle given the center and the radius? So we know, just like before, here's the center, here's the radius. You know what to do at this point. It's going to be x -2. That one's going to be a dead giveaway because it was the same. What are you going to do at that -7? Y +7 squared. And then we're going to do 8 squared. 8 squared is 64. So that's going to be the equation of a circle with the center of 2, -7 and a radius of 8. Okay, so make sure you do your homework.